On the right side of this screen, we have a fully interactive counter application. By the end of this video, you are going to build this exact interface from scratch using the code on the left. This instant interactivity is powered entirely by React's most widely used hook, useState. If you build a counter using a standard JavaScript variable, you will notice a problem. Even if you update that variable's value behind the scenes, the number on the browser screen stays exactly the same. The interface remains static because React isn't monitoring that specific variable for changes. This flowchart shows how we solve that issue. The top path shows our standard variable failing to trigger a change. The bottom path shows a stateful variable. When this special variable updates, it automatically notifies the virtual DOM to re-render, ensuring the browser screen reflects the new data instantly. Mastering how to create and update these stateful variables is the foundational step in making any React application respond dynamically to user input. Let's write the code. Step 1 is setting up our environment. Inside your source folder, create a new file named counter.jsx and declare a functional component. Look at the exact syntax at the top of the file. We use object destructuring to extract the useState function directly from the React library. Keep in mind that hooks only work inside functional components, so ensure you are not writing an older class-based component. With the tool imported, we can declare our stateful variable directly inside our component function. This array destructuring returns two elements. First, count is the stateful variable holding our numerical data. Second is setCount, the dedicated setter function used to update count. Finally, the 0 passed into useState sets our starting state, so the counter begins at 0. This declaration gives your component a memory, providing a current value to display, and a dedicated path to modify that data whenever you need. Now with our state, we need 3 JavaScript arrow functions for our interactive logic: an increment function, a decrement function, and a reset function. When writing these functions, there is a strict rule you must follow. You cannot attempt to mutate the state variable directly using basic math operators like count equals count plus 1. This graphic demonstrates the correct methodology. The direct equation on the left fails to notify React of the change. On the right side, we calculate our new value inside the parentheses and pass it directly into the setter function. We apply this same logic to the other actions. For our decrement function, we pass in count minus 1. For the reset function, we simply pass in the number 0 to explicitly restart the sequence. Think of the setter function as a mandatory signal flare. Passing data through it is the only way to notify React that the state has changed and the user interface needs to be redrawn. We have our logic, now we build the layout. At the bottom of your component, return a div container. Inside it, place a paragraph tag for the display member, followed by 3 standard HTML buttons. To dynamically render our data, insert a set of curly braces within the paragraph element and type the count variable. Look how we wire the buttons to our logic. We use the onClick attribute and pass the function name inside curly braces. Notice that we provide the function reference without parentheses. If you add parentheses here, the function will execute immediately on page load, rather than waiting for the user's click. Save your code and check your live browser output. This is a raw, unstyled interface, but test your buttons. You should see the numbers successfully incrementing, decrementing, and resetting. By confirming the numbers change on screen, you have proven that your state logic and your visual UI are fully synchronized. The mechanics work. Now we just need to clean up the presentation. Back in your JSX, add a specific class name attribute to your container, your paragraph tag, and each of your 3 buttons. Switch over to your CSS style sheet. We will center the text alignment on the container, increase the paragraph font size to display a massive number, and assign fixed pixel dimensions, rounded borders, and a darker hover state to our buttons. The moment you save that CSS file, the browser preview updates, converting our raw HTML structure into the polished, modern application we started with. This cyclical flowchart illustrates the core workflow we just completed. We initialize the state, we display that variable in our JSX, and we trigger the setter function based on user actions. The setter forces React to redraw the screen, closing the loop. Mastering this stateful logic allows you to build React interfaces that respond to user input in real time, which is the core requirement for building modern web applications.